Well, welcome to part 1 of lesson 3 on trigonometry. We are going to be using this lesson to learn how to use the sine, cosine, and tangent ratios, the 3 trig functions, to find different side lengths in right triangles. So first off, we need to figure out what are trigonometric ratios. So any two right triangles that have congruent acute angles are similar by the angle-angle similarity postulate. We talked about that in our last chapter. And similar right triangles have the same ratio. They have proportional sides. And these give rise to what we call the trigonometric ratios. So the 3 trig ratios we are going to talk about are sine, cosine, and tangent. And for our basic definition here of our trig ratios, we are going to be at angle A. All of these will be at our reference point of angle A. The trig ratios are the same kind of ratios, but they're different if we're at a different angle. So I'll explain that more as we get into things. So the sine of angle A is equal to the length of the opposite leg divided by the length of the hypotenuse. So it's a ratio of 2 side lengths. And in this example, if we are at A, the opposite side would be little a right here, and the hypotenuse would be side C, little c. So the sine of A is just the ratio of those 2 side lengths. Okay? The cosine is similar to the sine, but instead of the opposite leg, it's the adjacent leg. So instead of having the opposite leg A, we have the adjacent. Remember, adjacent means next to. So the side that's adjacent to A is side B, it's leg B, and it's still divided by the hypotenuse, which is C. The tangent function doesn't use the hypotenuse, it uses the opposite side over the adjacent side. Alright, so there are ways that we can abbreviate those ratios. The sine of A we will say is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. I will be requiring you to remember these definitions without using your notes. These are things you need to commit to memory. And one of the mnemonic devices that just about everybody knows once they get through geometry is called SOHCAHTOA. And this is to help you remember those 3 trig ratios. What these letters mean: the S stands for sine, it's opposite over hypotenuse. The C stands for cosine, which is adjacent over hypotenuse. The T stands for tangent, and it's opposite over adjacent. So you'll hear us refer to SOHCAHTOA, and that helps us to remember what each of the definitions of those 3 trig functions are. So let's go ahead and solve some problems using our trig ratios. So first off, if I want to find the sine of angle T right here, if I'm at angle T, remember the sine is opposite over hypotenuse, so that's going to be 8 over 17, and there are no units, it's just that ratio. Cosine then, remember, is adjacent over hypotenuse, so that one will be 15 over 17. And tangent is opposite over adjacent, which is 8 over 15. So here's a chance for you to try this on your own. Now let's change your reference angle. Instead of angle T, let's move you up to angle G in the same triangle. See if you can find the ratios for sine, cosine, and tangent for angle G. Go ahead and pause the video and we'll give you the answers when you get back. Alright, hope you took a look at those. Let's go ahead and define what those are. So we want sine, cosine, and tangent of angle G. So the sine of G, remember that's the opposite over hypotenuse. I'm going to abbreviate that O over H. And so the opposite side, if I'm up here at side G, and I look to the opposite, that's going to be 15. So that number will be 15. The hypotenuse is the longest leg opposite the 90-degree angle, and that's 17. So 15 over 17. The cosine of angle G is equal to the adjacent over hypotenuse. Okay? And remember, the adjacent side is the one that's next to that angle. So this time it's going to be the number 8 over the hypotenuse, which is still 17. And the tangent function of angle G, tangent of G, is equal to the opposite divided by the adjacent. And so the opposite side we said was 15. The adjacent side is 8. And you don't need to worry about these. Don't change these into mixed numbers. Keep them as improper fractions when we're dealing with these trig functions. Alright, so here's another example using trig ratios to find distance. And this one is a landmark with the Leaning Tower of Pisa. And they have actually done some work on that and were able to obtain a correction of 0.5 degrees in the Leaning Tower of Pisa. So suppose somebody drops an object from the tower up here at the top of this triangle, and this is at a height of 150 feet from the ground. How far from the base, down here x, how far from the base of the tower will the object land? Okay, and we know that this angle is 5 degrees. We know the height here is 150 feet. We want to know this length right here. Okay, so if we are up here at this 5-degree angle, x is the opposite side. The 150 length would be the adjacent. So we know opposite and adjacent. Okay, so what trig function would we use? We're going to use the tangent function because it uses opposite and adjacent. So we can say the tangent of 5 degrees is equal to the opposite side, which is x, the adjacent side, which is 150. And so now we need to solve this for x. Okay, x is being divided by 150. To get x by itself, we need to multiply by 150 on both sides. Okay, so let me just write that in there so that's pretty clear. So if I multiply this times 150 right here, and multiply this times 150, okay, these 150s cancel, and I'm left with x equals 150 times the tangent of 5. So I just wanted to make sure you could see what was going on there. So we have x equals 150 times the tangent of 5. Now this is a calculator problem. To find the tangent of 5 degrees, okay, that's a defined ratio, and so your calculator can do this. So you're going to press the tangent button on your calculator and then the number 5. Now the thing you need to make sure is that you are in degree mode and not radian mode in your calculator. If you don't understand what that means, please ask me in class and we'll talk about that. Okay, so we're going to hit 150 tan 5 and then enter. And your calculator should give you some decimal number. That's 13.123, and I don't know how many decimals you'll get. But that would be the distance away. So we would be about 13 feet away from the base of the tower. Here's one for you to try. Okay, you are given an angle measure of 17 degrees, a length of 150 feet. Find the opposite side here, x. All right, let's take a look at how to get the solution to this one. So our angle measure is 17 degrees. X is the opposite side and 150 is adjacent. Or excuse me, it's not adjacent, it is the hypotenuse, right? Because we have a right angle right here. I should have written that in there for you. That is a right angle. So this one is the hypotenuse, right? This side over here is opposite the 17-degree angle. So which trig function uses the opposite and hypotenuse? Well, that would be the sine function, right? Sine is equal to opposite over hypotenuse. That's by definition. So we're going to say the sine, and we abbreviate sine with just sin. It looks like sin, but it's sine. 17 degrees is equal to the opposite leg, which is x, over the hypotenuse, which is 150. Now how do we solve this for x? We need to get x by itself. X is being divided by 150, so we want to multiply by 150. And whatever we do to one side of an equation, we must do to the other. So I'm going to multiply the right side by 150 as well. Okay, these 150s will cancel, leaving me only with x on this side. So x is equal to 150 times the sine of 17 degrees. Okay, so what I need you to punch into your calculator, you can go ahead and do this right in order on most of your calculators. So you're going to punch in 150 and then sine of 17. And my calculator is giving me a value of 43.9 looks like 9 degrees. Okay, and we want to or 43.9, excuse me, it's not degrees, my bad. It's 43.9 feet. Okay, we're not looking for the angle measure. That'll be in our next lesson. We are looking for that distance right there, right? So 150 times the sine of x, sine of 17 is equal to x, so x equals 43.9 feet are our units, right? To the nearest foot, we're going to call that 44 feet. All right, here's your lesson check. Using the triangle on the right-hand side, go ahead and find the sine, cosine, and tangent of both angles A and B. So you'll get 6 different answers to those, and bring those to class. We'll see you next time.